Okay, thank you for coming to my talk. If you haven't already, follow me on Twitter. Like I said, it makes me happy. If you want to read about who I am, what I do, I have a website for that. The important thing for this talk is to know that I'm a programmer who spent a lot of time reading other people's code and not always enjoying that. I'm very happy to see that so many of you are skipping the useful talks and have come to a different kind of talk, because that's where you are. The reason that I got into this kind of topic, thinking about what code looks like, is that I've spent a lot of time thinking about reading code and code being maintainable. So the serious thing is a kind of doing training on maintainable code. This is not that talk. This is something that I started thinking about when I read this, about how as programmers we spend much more time reading code than we do writing code. And yet our tools don't seem to acknowledge this. Our tools seem to be focused on the experience of writing code. It's almost like we're focused on how nice it is to write code, but we don't really care about the people who have to read it, which would almost make sense, except those people are ourselves as well. You probably even spend more time reading your own code, thinking, who wrote this and what were they thinking, than you do even writing it. So one of the things that I wish I had was code with better type. Now, this is not the FP track, so I do not mean a better type system. I mean code with better type as in typography, as in typewriter. This is an IBM Selectric typewriter from 1961. This is a pretty advanced typewriter. Back in the day, this had an innovation. It had one of these. So the type head was colloquially called a golf ball because it's kind of golf ball sized. And the innovation was that you could remove it and replace it with a different one, with a different typeface. This typewriter had 45 different typefaces. That is very cool. In fact, one of those typefaces was commissioned especially for this typewriter by IBM, and that typeface is called Courier. It was new in 1961. Courier was designed to work well with typewriter technology, to be clearly legible, to have exaggerated letter shapes. This was an early focus on usability before anybody had thought of the term UX. So this was pretty, state-of-the-art hardware printing technology, but consumer-level printing technology for the day, for 1961. Did programmers use this exciting new hardware technology for printing code? No, they did not. At the time, code looked like this. This is code printed out on a line printer. Programmers used line printers, which were nothing less than a crime to typography. They were optimized, I think, just for speed of churning out pages. And reading this stuff was unpleasant, and not because this is COBOL. There's nothing intrinsically unpleasant about that. I hear that's only unpleasant to write. But this was unpleasant because there's just no typography going on here, no attention to letter forms, and more importantly, no attention to readability. And so for me, typography is maybe a little bit about the beauty of beautiful typefaces, but it's far more about the user experience, about the readability of text in the correct typeface, and type that communicates the right kind of idea. Reading a novel printed on one of these would just be unpleasant. You wouldn't want to do that. Anyway, that's 1960s. Years later, a new technology for type was introduced in Windows 3.1. And in Windows 3.1, Microsoft commissioned a new version of Courier called Courier New, which would be the default monospace typeface in Windows 3.1. The difference was that Courier's lines are too thick, and for the typeface to be readable at common sizes on low-resolution monitors that we had in the day, it had to be thinner, so that the strokes, the lines, would be 1 pixel wide. That was really part of the Windows 3.1 aesthetic. And because of this, perhaps, it became, I guess, a kind of default programming font for many people because it was the default monospace font. So it has become somewhat associated with code. Now, this is kind of strange because, by the time Windows 3.1 came out, of course, typewriters are pretty much gone. They're now obsolete technology. And people who used to use typewriters are now using word processors, sometimes running on Windows 3.1 or sometimes dedicated hardware. And so they've got things like WYSIWYG font rendering, rich text. And were programmers using rich text for source code? No, they were not, because programmers, by this point, had caught up with the typewriter era and were using Courier or Courier New when printing code. I mean, this is from much later than the last year that it was reasonable to be using a typewriter from a typography point of view. It's just old technology. And you would think that this has completely gone away. I mean, I would expect that maybe none of us, or maybe only a few people in the room actually use Courier as the font in their IDE. That's not really the popular thing. But it does still appear, especially in printing code. That's especially weird. So, I mean, perhaps my only claim to fame is this book about a Scala web framework. But the saddest thing that happened in the publication of this book was my failed argument with the publisher about printing the source code examples. And so this Scala code is printed in Courier New, which is appalling. And they refuse to use a proper font. They refuse to use something that would be less ugly, because Courier is, let's face it, ugly, and something that would maybe be more elegant, take up less space. And Courier is very wide. We had to format the code examples to maximum 55 columns. I mean, that's horrible, because I like long variable names. It was really sort of unpleasant to do, but they insisted. And this is not only deeply ironic, because not only ugly, but also ironic because it's a book for print. You know, I've got paper copies of this book. And in print, none of the constraints that applied to Courier or to Courier New were relevant. You see, Courier had to work on a typewriter. Courier New had to work on low-resolution displays. But in print, you have thousands of dots per inch. You have high-resolution printing. You can use any typeface you like. You don't need those compromises. And so there's something cultural going on. For no good technical reason, we're using a typeface that was designed with compromises in mind when these compromises are no longer necessary. That may be sad. But as I said, we probably don't use Courier in our IDEs, in our text editors. So mandatory audience participation, sorry, but put your hand up if you use a different font when you write code, if you don't use Courier. Indeed, almost everybody, maybe even everybody. Because we have new fonts. So we have new fonts, but new fonts have cropped up occasionally over the years. But we have also, as the decades pass by, something much more exciting. We got color. Now, I mean, we didn't get color straight away as programmers. This is a late 1960s Sony television. Now, I'm pretty old, but I'm not old enough to have actually, had one of these at home. This is from 1969, and, color makes a big difference to presenting information. I mean, if you had something complex like, I don't know, source code, maybe that's a useful thing. Indeed, the first time I had color on my computer was when I was a teenager. I had one of these, 1982 model Sinclair ZX Spectrum. Now, this had color, 1982. Programmers didn't have color code in 1982. That came much later. So syntax highlighting was the next big innovation. The earliest report I've heard of syntax highlighting is version 7.0 of Turbo Pascal in 1992. So only 10 years later, only 10 years after my ZX Spectrum, we had syntax highlighting in code. And syntax highlighting is indeed, these days, pretty much universal when you're reading and writing code. It's very useful. What an excellent idea. This, incidentally, is quite an interesting piece of code that I've plucked from a Wikipedia page because it fits on the slide. But it's interesting because, although it's quite short, not all of the lines are equally interesting. It's got the most gratuitous magic number in the history of programming in the middle of a floating point calculation, and with some appropriate comments. I even had comments. I don't know, maybe the comments are more shocking that there are comments in this code. But if you need to understand this code, you should maybe start in the middle. Maybe you shouldn't, read it top to bottom. You should, it takes a while to digest. I mean, and there's lots of interesting things in there to pick out. But the presentation doesn't help very much. I mean, we have syntax highlighting to make it easier to see what's code and what's a comment. But what if there was a better way to highlight the most interesting thing about this code, other than the profanity in the comment? But this is almost state of the art. Incidentally, this is the Consolas typeface, which, in not a coincidence again, Microsoft commissioned for a yet newer type technology. When we all got LCD displays, Microsoft invented ClearType. ClearType uses sub-pixel font rendering to give you clearer typefaces on contemporary monitors, and introduced a bunch of new typefaces whose names begin with C, including Consolas. Very good coding font. And so, we've got new fonts. So we've got new fonts and we've got color. One more thing, we've got more than that. I mean, this is already, pretty exciting, but there's another innovation, and it's like all things in software. It's new, but not at all new, really. This has been around for a while. So we have ligatures now. So in typography, a ligature is when you have two characters that, when printed next to each other, would overlap in a kind of ugly way. And so the solution is to make a new character, like the TH, which the rendering technology on your computer will automatically replace the original two characters with, to make the join nice. So technically, in the typeface, it's a separate glyph. It's a separate character image. And when you type on, when you type on a computer, the computer automatically switches for the combined character. So the TH one is kind of subtle. The FJ combination is a little bit easier to see. The dot on the J, on the lowercase j, would get in the way of the ascender, the overhanging ascender on the F. And so in the ligature, they're combined. And in fact, the two letters are joined together in a pleasing way in this particular typeface. It just so happens that in the English language, there is precisely one word that uses this FJ combination, and that's fjord. So I guess it's not so useful in English, but it does appear there. Maybe in other languages, this FJ combination is more common. I don't know. And so here is a coding font, Fira Code, that applies the same technology in a very creative way. It gets pairs of characters, and when you type them together, it replaces it with a completely different character. The font is based on Fira Mono, which you see on the left. And so this means that when you type an exclamation mark, a bang, followed by an equal sign, you get a proper not equal sign, like you might have seen at school when you were a kid learning mathematics. Not the ASCII art characters that we are used to in programming, because most of our symbolic code is just ASCII art for proper mathematical operators. And once you've done this, once you've realized that you can have a proper greater than or equal sign, top right on the slide, you can do much more funky things, like have proper arrows rather than just ASCII art arrows. And you can even do exceedingly cute things, like the funky joined together www on the bottom right corner. And so this, if you use this makes your code much nicer. So who's already got Fira Code installed? Okay, so that's a minority. So the rest of you, this is your lucky day. Tonight, you can go home and experience the state of the art in code typography by downloading this open source font and using it for your coding font from now on. Don't go to sleep until you have done this tonight. Install this font. This is maybe the best thing that's going to happen to you this week. This will transform your coding experience. So fortunately, I have done something useful. This makes me very pleased. So let's recap. Programming has been a thing for quite a long time, certainly longer than I've been alive, half a century or more even. And over the last 60 years, we've had a number of major innovations in source code typography. We've got a series of new typefaces for the latest technology. We've got syntax highlighting, sometimes even including italics and bold, and we have ligatures. So I'm not really impressed, because typography, starting with people chiseling letter forms out of stone, typography is 3,000 or 4,000 years old, as far as you count it. And in this last 50 years, we've barely touched that. In fact, in any period, there's been more innovation in typography than we've seen in the history of our craft. So this is this is a little bit sad, but most of all, it is a huge mystery. Why, as programmers, why, as coders, users of code, are we writing code that is the only form, the only expression of text in modern civilization that denies the existence of typography? Everything else, every throwaway product brochure, conference badge, restaurant menu, pays more attention to layout and typography than our code. And it's worse, because the hardware has changed again. So I mentioned that Consolas was introduced when we got LCD monitors. And what's happened since then? Well, we still have LCD monitors. The resolution's getting better. But most of all, they're getting more numerous on our desk, and they're getting wider. And so there was a time, I guess in Windows time, we had kind of monitors that look really square. If you see them now in photos, it's kind of weird. But now we have wider monitors. You should have at least 2. So if there's anybody here who doesn't have at least 2 monitors, tell your boss that I said that you have to have at least 2 monitors, and that 3 will make you a more productive, happier person. So do that. But yeah, so we have many monitors. This is the evolution of our current kind of technology for reading code. It's spread out across our field of vision. Thing is, as a coder writing, and maintaining code that's, classes in the code base, what does the code look like on my monitor? Well, the code looks like this, because every code base I've worked on has classes that are too long, and they're this kind of thin strip, would be if I kind of filled them on the monitor. So on this slide, that's 530-ish lines of code. I mean, it's not even that much. I mean, how long should a class be? I guess, classes are supposed to be shortish, right? I mean, that's what we were told at school. So how short is shortish? Like, is 500 lines short enough, maybe? I mean, how many classes are there in your code base that are more than 1,000 lines long? Probably more than there should be. Pick a number, pick a number. What's short enough? I mean, let's even suppose that you thought 500 lines was short enough and somehow you can cope with this. How many lines have you committed to your Git repo since the last time you added a new class? Probably more than 500. And yet, despite the preponderance of source files that are longer than they ought to be, and refactoring that hasn't happened, our IDEs don't let us use the space on the monitor. We have bento box IDEs. That's the user interface paradigm where you carve up the screen into little kind of rectangular areas, and only one of them has the code in. It seems like a waste. And of course, you can't see this much code at once. You just see a little bit, and you have to scroll around. So what could you do? What if you use multiple columns for the code? That when you get to the bottom of the screen, you just kind of start another column, and you could have much more code on the screen. That would be really great. I suppose that you would then scroll sideways and have additional columns. And if you have more monitors, it would just keep going. I'm already liking the idea. This would be great. And so this is a very simple additional idea. But nobody's done this. I'm not sure why not. So that's the first thing I want you to think about. Why has nobody done this? And then I want all of you to go to JetBrains' booth after this talk and demand that they add this feature. Problem. There are problems. I mean, obviously you can't find anything here. It's all a bit of a mess. So I figured that you could do something else. And I thought, what if I just went wild here? I mean, I've already broken all of the rules. So what if I had, in the same source code, more than one font size? And make like the method signatures bigger. Now it's starting to look a bit messy because I've got this indentation and it doesn't line up and it's not very tidy. And I feel a bit uncomfortable when it's not tidy. But I figured that if I draw some lines in between the columns and in between the methods, then it starts to look a little bit tidier again. I might as well go all the way because I'm not inventing this visual language, this layout style. This is just what newspapers used to look like. So I apologize for showing Java code. At a .NET conference, but the principle is exactly the same. And so what I've done by just doing a few simple things that somehow have not been applied to code, I have brought this example of code up to the level of the first edition of the Oxford Gazette, which was the first newspaper published in England in 1655. So, this was the state of the art, or not even the state of the art, but just common practice 360 odd years ago. And already, like, this is way beyond what we've ever considered as programmers. This is a shame. Meanwhile, I mean, the monitors, well, actually, no, we did get color since then. They didn't have color printing in the 17th century, so I guess there's that. Anyway, meanwhile, hardware technology is improving, and the monitors just keep getting wider. So wide that they have to curve, because otherwise, when you look at it, it's kind of different distances away. I'm not sure if this is good for your neck working with one of these. I'm also not sure if this is really intended for gaming, or this one, which is quite special, that you can rotate. This is really just, a coding monitor for long classes. I want one. Actually, I want several, but only if I've got columns, right? Anyway. So the simplest kind of layout would already be quite exciting. What else could we do? Now, it just so happens that not all software is written within the same subculture. I always write business software. Some people write games. So it just so happens that the fast inverse square root is used in graphics calculations for 3D graphics. It originally comes apparently from Silicon graphics workstations back in the 80s maybe, but was also used in Quake 3's clone, Open Arena, which is much more recent. This is not much more than 10 years old. And so the 3D graphics routines need very fast, optimized routines for calculating, I guess, things like light reflection angles, hence the use of a fast inverse square root calculation. So the usual aesthetic for code doesn't necessarily match this. Or maybe if you're a coder working in games, then you definitely have a different color theme. So I thought, what can I do in typography? If I put some code in a desktop publishing program that gives me typographical control, I could do all sorts of things. I could use more than one typeface at the same time. I could use a dark color scheme. You should definitely have a dark theme if it's game code, right? And I could use heading style like I did in the previous example. I could think about two-dimensional layout. I mean, not just have everything go in a vertical column and highlight things, because there was one very interesting thing in that code that I should absolutely highlight. Special characters, I mean, follow the inspiration of Fira code to use the correct character when it appears. And so I just had a little play. I mean, this is kind of where this talk came from, as a conversation in a pub, and I could do this. And then I thought, this is it's fun and it's frivolous, but what if we could make posters out of code? I don't care if you can't do this automatically. I don't care if it takes a designer a week to make this. But if this is the most interesting code in the code base, I want it A0 size on the wall in the room where we code, so that new people can be told, this is where you start in the code base. So I did all of those things. And I even, in the big number, once you make text really big, the spacing looks a bit kind of awkward. So, it's a typography thing to adjust the letter spacing, the kerning between the digits in the big number to make it just look a bit more tight and punchy. And I'm not even the designer. I mean, this is just me messing around. Of course, I did realize after I'd done this that I write corporate code. I've always done business-to-business stuff. This game stuff is much less serious in a way. And the code that I'm writing or maintaining, actually usually maintaining more than writing. Remember what I said earlier, I'm reading other people's code, not writing my own. Just trying to fix their bugs. Anyway, this code should look much more corporate. So what does corporate look like? For me, corporate is the corporate report, the annual report, with the stock photography and the glossy cover. I think the code from the newspaper, for example, should actually really look something like this, you see. I want code to have photography. And a factory bean is kind of a serious, grim kind of thing. So I want a serious-looking factory control panel photo for this. I want to set the mood for this class. You know, it's not just code. I mean, there might be some happier classes somewhere else. Maybe the exceptions have, you know, pictures of natural disasters or whatever. And actually thinking more about the picture, I mean, even before I look at the text, so slight aside, because the picture has nothing to do with typography. But, you know, graphics and text go together. The picture, what if it wasn't just a static photo? I mean, if there were test failures, maybe the control panel's, you know, on fire. That would be kind of cool. I mean, it'd have to be computer graphics, but CGI is pretty cool. And I could go off in a whole direction here about headsets and, you know, getting into the code and walking around some Half-Life style environment where there are aliens, you know, which are the bugs, and killing them. Anyway, let's not do that. Let's not go there. Just back to the text. I guess it helps if your language supports non-breaking space characters, so you can put spaces in the names, because you know, having to kind of, you know, put all these long variable names in one word, that's just kind of not very readable. It turns out that if you put spaces in between words, it's easier to read, better user experience. Or maybe we should call it better developer experience, DX, because, you know, hot take, developers are people too. And what else can we do here? So what I've got here is I've got a whole load of documentation comments on the right, which is in black. And there's loads of metadata garbage in code headers that you don't really need to see, the license, the import statement. So that can all go on the left. And I can actually separate the documentation comments from the code itself and, you know, put them in, use columns for that. Put line comments, you know, that's the thing that's right aligned in the first column. So what I've done here is I've picked a different layout and typography style. I've picked the textbook as my inspiration for what corporate code might look like. And I haven't done very much. I mean, I didn't go very far with this. But just doing some simple things probably makes this much easier to browse, much easier to read. One of the things, you know, and if I've got multiple monitors, then I can have my double page layout. I don't know, it's kind of pleasing. What if you had a real designer? What could they do? There's something else that I did here, which I'll have to zoom in so you can see it properly. We've got high-res monitors now. So we're not quite at the stage where our desktop monitors are the same resolution as our phones, you know, hundreds of dots per inch. But, you know, there are new monitors which are more than 200 dots per inch. If you've got decent resolution, you certainly don't need monospace fonts anymore, so you can use a proportional font. If you ever want to completely troll your colleagues, especially when doing pair programming, try changing your programming font to something that's not monospace. You know, assuming that works in your IDE, because it doesn't always. I mean, some IDEs just assume that it has to be a monospace font. The sky does not crash, civilization does not end. It works. Maybe you even get to see more code in a narrower space, because monospace typefaces are very space inefficient. You know, and if your monitor is clear enough, if the resolution is sharp enough, it's going to be just as legible. We don't need those workarounds anymore. We are stuck with 1970s workarounds that have somehow become ingrained in our culture generations later that we don't dare question them. And we complain if people question these. So when you try that experiment, I did this years ago. I used Verdana as my coding font just to see what it would be like. I don't know, I was bored or something. It was fine from my point of view, not a biggie. It really annoyed my colleagues. So there's may or may not be a bonus from your point of view. It's worth noting that one of the kind of objections that people make when it comes to talking about not using monospace typeface is that the layout would no longer work. So I push them, what do they mean? It turns out that some people, you know, and I'm talking to you now, line up things underneath equal signs. Well, that's just kind of, I don't want to say it too bad, but it's bad. Apart from anything else, if you rename a variable, which you should absolutely do when you come up with a better name, it's going to pollute the diffs of the adjacent lines, because, you know, the equal signs will move and they'll all have to move. Go language does this in its format tool automatically, which is a bit of a shame. And so you don't need to do that. You don't need to, you know, lay things out like that. And in fact, the whole idea of using spaces or tabs, I don't care, for layout is also just wrong. Because if you're designing that restaurant menu or that newspaper front page or a magazine article and you want something a bit further to the right, you just move it a bit further to the right. Or maybe you type, you know, plus 1.5 millimeters into your tool. What you don't do is add a space. I mean, can you imagine that in the design section of a newspaper, somebody saying, move that to the left a bit, and somebody saying, what, space or tab? It just doesn't make any sense at all. I mean, even CSS, right? So back in the day, before the web, there was just Gopher, and it was all text-based, and then the very first version of web pages was already more sophisticated. And then we got CSS, which is based on print typography and layout. And so, already by the mid-90s, web pages were more sophisticated than code. That took just a couple of years. CSS 1.0, blows away what we can do with code in our editor. So we don't need fixed whip typefaces because of high-res monitors. So where am I going with this? I think the ultimate end was to realize that there's a whole discipline of typography, layout, design. It's a different thing to programming, and it's different people. But I work for a product company, and there's product department, there's an engineering department where we build the product. But there's also a marketing department where they do things like market the products with online materials, but also brochures, folders, little leaflets that they print out and give out at conferences. There are designers working for the marketing department who make those leaflets. The designers are wasted in marketing. The designers should be on the coding teams. And so I believe that we would be better off if we had a designer on every development team who, instead of working on a product leaflet or poster, which is going to be thrown away after a few months because the marketing changes, is going to instead make leaflets and posters and coffee table books for the most important code in the code base, because that stuff lasts years. And the code may change it occasionally, so they can just manually update it. I think it would be completely reasonable to say, you recently spent a couple of days designing a product brochure. Well, how about you now spend a couple of days designing an infographic poster for this, which is our most important class, which will be around for years. I can't quite work out how to actually get away with this. And so this is where I realized that I'd probably reach some kind of dead end in my reasoning. But although it's obviously not going to happen anywhere I've ever worked, it's also not obviously wrong as an idea. And I'm pretty convinced that we're missing out on this whole discipline in our code. But what is happening? Where is the innovation in code? So we could absolutely have better typography on the code when we read it, better layout that would help us, that would make it more readable, more maintainable. The innovation is not happening where I was looking. It turns out it's happening somewhere else. So I'd like to share a few ideas and a few observations about where is the innovation in what code looks like. Now, particularly the inspiration for much of this comes from this presentation called The Future of Programming by Bret Victor. So who has seen this presentation online, maybe, or even in real life? That was like 3 people. So all of the rest of you, I am now going to make your day by telling you that before you go to sleep tonight, you must absolutely find this talk on YouTube and watch it, because apart from anything else, it's much better than this one. And in this talk, he pretends it's 1973. And he talks about all of the wonderful things that are obviously going to happen in the future of programming, based on all of the wonderful things that happened in the 60s when people were very creative. And he's full of optimistic certainty about how programming has will soon, in just a couple of decades, become so much more interesting. And at one point, he does say, in the talk, he says, "I'm totally confident that in 40 years, we won't be writing code in text files." He said, I think it would be kind of a shame if we're still coding in procedures, in text files, in sequential programming models. That would suggest that we didn't learn anything from this really fertile period in computer science. That would be a tragedy. And so by looking back on the 1960s and thinking in the future, we can see that the tragedy happened. And 40 years later, more than 40 years later, we still write code in text files. We're using 1970s technology as the basis of all of our tools, our whole tool chain. There's an opportunity there to do some reinvention. It's problematic because if you want to do something weird, like have a programming environment that doesn't save the code in text files, then the whole tool chain that we normally rely on, things like version control, suddenly don't work anymore. But surely that would be a wonderful thing. After all, as programmers, we love nothing more than writing code for other programmers, ideally ourselves, because this saves us from having to talk to normal people, non-programmers, that's what I mean. And so you'd have to reinvent the whole tool chain. You wouldn't just use the stuff that was basically developed in the 70s for Unix. You get to build everything all over again. Surely that would be a great benefit of having to start from scratch. I don't know, just a thought. So it turns out that there are some new things. It's not quite as bleak as Bret Victor pointed out in 1973, or in fake 1973. And so I just want to briefly show you a couple of examples for different audiences. Scratch and BPMN. BPMN is Business Process Model and Notation. It's an object management group standard for modeling and presenting business process models. Now, it turns out that there are tools for actually executing these models. So if you've got some representation of a process and you can execute it, that representation is essentially code. Scratch, meanwhile, is a visual programming environment for children. It's very popular in various places. And I guess from about 8 years old or something, it's a completely accessible approach to programming, and it's really designed for that. And it also uses executable visual code elements. Now, because of the text on the elements, it's a little bit more obvious what they do. You have sort of sequences of instructions that go from top to bottom. Now, it turns out that both of these visual notations in different ways express basic procedural programming. So, a box is an action, and you can chain them together in one way or another. And as soon as you have conditions and loops, you can probably do more or less everything. In fact, both languages are richer than that, but they're rich enough to get into trouble. The main difference is their intended audience. Scratch, as I said, is for children. BPMN is for operations managers, business people, people who work with spreadsheets, finance people. I guess another main difference is that Scratch is way more sophisticated of the two. Scratch for managers, the BPMN thing, that's simpler. But that's okay. Anyway, so if you step away from the idea that code is text files, it behaves differently, and you can do a couple of different things. So one of these is the difference of what you get from zooming out on your code. So we don't see this kind of zoomed out class on our monitors because this has pretty much no value. I mean, you might have a little mini-map in your text editor, depending on what you're using, but it doesn't help that much. It's not that meaningful. Whereas if you zoom out on a BPMN diagram slightly too much to be able to read the text, you can still see some kind of visual structure. And you still have some flexibility about the layout. And so in this diagram, the 5 boxes that are vertically on top of each other, that has some kind of significance. That does mean something. There is some kind of recognizable structure. And in fact, in this language, code patterns are literally visual patterns that you recognize visually. And that comes from the expressivity of doing layout. And you have a similar thing in Scratch as well. So this program is a bit long and a bit messy. So we can see that already from zooming out. But we can still see the colors. Even if we can't read the text, we can see the colors, and Scratch color codes different kinds of statements. So this tells us something. You can see where the conditions are, where the loops are, even if you can't see what they actually are. So zoom becomes a thing. Zoom was never a thing in code before, at least in the kind of code we're used to. Another thing you can do if you're not saving the syntax tree, which is effectively what you have in a code in programming language, if you're not saving that in text files, you can do things like localize it to different languages. So it doesn't have to be in English. Now, this is very important for 8-year-olds because requiring code to be in English would, raise the barrier for getting started. And somehow we have this acceptance as programmers, especially as professional programmers, that it's totally cool if there are huge learning cliffs on our technology and huge barriers to getting started. But what if we did all of the things that we do for kids, but for ourselves? I mean, surely, we need to make it easier for children, but why does it have to be hard for everybody who's not a child? And that's just the beginning, because Scratch Scratch uses this sort of web-based visual programming environment where you're programming what some characters do. And it's got this real-time live debugging thing. I mean, Scratch is kind of sophisticated. It's some kind of event-based real-time programming environment, and you can do real-time debugging, and it's super cool. There's lots of sophisticated things going on there. And lots of things that just don't really work if it's on text files. Another thing that's wrong, or a missed opportunity if it's just in text files, is that those text files in the first instance are probably on your own laptop, whereas Scratch is web-based. It's online by default. And so if you go to the Scratch website, it tells you that you can create these programs, these animations, these games, whatever, and you can share them, because in the top right corner, now you can't see it on this picture. In the corner of the environment, there's a share button. You can share your programs. You've got one click, push to public source code repository. And if you select Explore on the website, you can browse currently 32.5 million projects. Now, I don't know, maybe you're not impressed because that's barely half the number of repos that GitHub has. But it is, for the most part, just children. And so I guess 32.5 million is quite a large number. And I have done this presentation before, and I have to update the number on the slide. It grows quite fast. I mean, this is really a thing. This is not a toy in the sense of it's not real. It's a toy in the sense of, I guess, we're not building, business database applications from scratch. But, kids are using it, and they get a lot out of it. So that ability to be able to view source and copy other people's code is very important for learning. This is not built into our normal programming environments, because there's something in the way called Git for many of us. I like language jokes. It's a common thing for English people, I guess, an affliction. And it turns out that, of course, Git is an English word. I mean, it's colloquial British English. It means a not very nice person, which is a very clear description of the usability of Git, the programming tool. Why does it have to be that hard? In Scratch, if you see a program that you're browsing that you like, you click the remix button. That's a one-click fork. It could be that easy. So what is the takeaway from this observation of these coding environments, Scratch and BPMN? And there are many others, especially in the field of data science, especially in other fields, that they do have something in common. It turns out that they are pretty much always aimed at, intended for people who do not consider themselves to be programmers. And I think there's two parallel reasons for this. One is that if you want to get kids to do something, we understand and accept that it needs to be as easy as possible. If you want to get managers to code something, it needs to be very easy. But it turns out that there's a lot of value from that. Microsoft Excel is also programming. That's most business programming. And you can just get started using it in a way that you can't with the kind of programming we do. And of course, the other problem is that if you push these kind of visual programming environments towards conventional professional programmers, which is most of us, we tend to reject it immediately. And I'm not sure if it's because we want to stay in the 1970s or because we think it's not real programming. But calling something not real programming is mostly just a sign that you're being an asshole and not allowing other people to enjoy programming as well. Because these other things, including Microsoft Excel, are absolutely real programming. Be more inclusive in your communities. So all of the innovation is for these reasons. We're not getting it. It's going elsewhere. So what does that mean for us? Well, what I think it might mean for us, and this worries me a little bit, is related to this. This is a photo of an 80-column punch card. Now, I'm not old enough to have actually seen one of these, certainly not to have ever written code on one of these. But my rough high-level understanding is that you punch holes in them, and that represents binary encoded numbers that represent machine code instructions on the machine you're going to feed the card into. We don't use these anymore. I can't even imagine trying to program using these. That just must have been absolutely horrible. So when when machine language programming was replaced with, well, not replaced, when assembly language was introduced, the people who did machine code programming, they said, well, that's not real programming. This is real, you've got to write machine code. I mean, how do you even know what's going on if you write assembly language? But inevitably, the convenience won, and assembly language, became popular. I mean, people wrote whole operating systems in it. But at a certain point, high-level languages like C were introduced. And of course, what did the assembly language programmers say? They said, that's not real programming. How do you know what's even going on? What did the C programmers say about garbage collection? So the cycle repeats itself. And we get these newer programming languages. And discussing old versus new, shiny versus less shiny programming languages seems to occupy a lot of our time as programmers. We argue about which programming language we use. When I run a local community meetup and completely novice programmers turn up, or people who want to switch to programming turn up, they always ask, what programming language should I use? And this usually generates quite a long-winded discussion amongst the old and jaded programmers who are present, because usually it starts off with somebody saying, it doesn't matter. Somebody else will say, well, yeah, it doesn't matter, but you shouldn't use JavaScript. And this sort of continues for a very long time until there's this kind of rough consensus at the end that you should probably use Python. I don't know, because it's something, it's friendliest. But all of the programming languages we're arguing about are, in some very real sense, all copies of either Lisp or Fortran in text files. And so arguing about whether your language, and I hang around in the Java community a lot. In the Java community, there's this joke that Java's the new COBOL. But that's entirely missing the point. Worrying about whether, is that true? Is C# safe? Or is C# also the new COBOL? You're entirely missing the point. That's not what you should worry about. You should absolutely worry about writing code printed on a typewriter in ASCII text files being the new punch cards. Because when the kids who've grown up on Scratch, graduate from their computer science degrees and start startups to make the next generation of programming languages and development environments, they're not going to want to stick with this. They're going to invent some kind of enterprise Scratch. And I have no idea what that is going to look like. But I do know from the talk this morning that anything anything I experience new after 35 is going to seem to me against the natural order of things. I'm going to have problem adjusting to that. So if we stick with our ASCII text files, we're basically sticking with punch cards and we're sticking with the typewriter. And the next generation is just going to take all of our jobs and we'll be out of work and we'll be sad. So we have an opportunity to, I don't want to end on that kind of sad note because that's kind of bad. But we do have an opportunity to think about more interesting kinds of programming tools, to recognize and notice that there are lots of communities who are non-conventional programmers using some really cool tools. And maybe we should get in on that. And maybe we should work out how can we modernize our tools so that we're no longer essentially writing code on a typewriter. Thank you very much. Would anybody like to ask questions in front of everybody else? Or you can just come and talk to me while I'm packing up my laptop. I don't see any hands. Okay, thank you.